All right, so number 8, it says write an expression that represents the total number of ways you can travel between city 2 and city 1, first by bus, then by subway, with no more than one connecting stop. What is the value of this expression, and what is the meaning of the result? So for starters, they want you to build a an expression. So that's like those equations with the I don't know, we did it earlier with the R's and stuff like that, where it's like R and then a number, comma, a number times R times, I think it was in lesson 2. Yeah, it was in lesson 2. So now they just want you to develop that expression rather than them say, hey, go find R12. What is the meaning of that? Now, figure out how you would multiply this. So let me kind of flip back to the very beginning. So when we're doing the diagram here, it says write an expression that represents the total number of ways. So that means buses and subways are included, but we first go by bus, then by subway to go from city 2 to city 1 with no more than one stop. So that means you can go straight from city 2 to 1, or you can go from city 2 to city 3 to city 1, city 2 to city 4 to city 1, but you can only stop one time. And I believe we did that already on part A, right? City 2 to city 1, first by bus, then by subway. So in that first opening exercise, we already got that written out. So this wants us to establish an equation. So we'll start off with we developed our matrices, I believe, on question right on number 4. There's a B equals a matrix and S equals a matrix to represent the buses and subways. So if I'm trying to connect all buses from city 2 to city 1, I would need to first establish, going back to that map, city 2 to city 1 for buses. So that would be like row 2, column 1. How many options do I have? So for instance, let me back up a little bit. Yes. So we filled out this chart right here. This chart right here with all the buses from all the routes to get from city 2 to city 1, first taking a bus, then a subway. So you can backtrack there. We then use that to help us build these matrices right here. So if I'm going from city 2 to city 1 by bus, I would look at row, then column. So city 2 to 1 tells me I need to go from row 2 to column 1. How many options were there? 2. All right, so when we're building our expression, instead of writing the number, we just write that expression. So to do that, it will be a lowercase b to represent the capital B buses, and you would just do 2, comma 1. And that would represent whatever that element is. We would then multiply that. That's what we did to the next one, on how many ways are there from subway to go from city 1 to city 1. 0. And again, if you backtrack to the subway matrix, if you go to row 1, column 1, what was that element there? That's a 2, comma 1 and a 1, comma 1 with a B and an S. Bus and subway. So that's what that math would be. So that's your expression. So then we would do that for all of them. So then we say plus, then we move on to the next one. We would go bus from city 2 to city 2 times subway from city 2 to city 1. Remember, these inside numbers must be the same because you can't teleport somewhere. And then the beginning is always going to be 2 because that's where we're starting. And the ending will always be a 1 because that's where we're ending. You see the pattern? What would the next one be? Good. B 2, comma 3, meaning I start at city 2, then I go to city 3. Times what? Perfect. Subway 3, comma 1. Again, those have to be the same, and I have to end at 1. What would my last one be? B2, comma 4 times what? Perfect. Any questions on that? Establish an expression. So that's that first part. write an expression, and then it says, what is the value of this expression? So now that we have all of our expressions, now we're going to go back and use the matrices to help us. So at B21, what's the element? Which means row 2, column 1. It's 2. What's the subway 1, 1? Bus 2, 2. Subway 2, 1. Bus 2, 3. Subway 3, 1. I think it's, yeah. If you go to S, that's hard for me to go back and forth. Go to S, go row 3, column 1 should be 1. Bus 2, 3. 2, 3. Bus 2, 3 would be at, oh, I got you. It would be 2. S 3, 1. 1 plus B 2, 4. S 4, 1. And then we just do the work. So this would be 0 plus 0 plus 2. Oh, did I do that twice? I did do that twice. I was like, there shouldn't be 5 of them. All right, so 0, 0, 2 plus 2, which gives me what? 4, which should pan out just like that first box we did in the open exercise whenever we last saw each other and did a lecture, because we also had TSI in between all this too. All right, so this is a great way to review. So what is the meaning of this result? What's that 4 mean? Perfect. Add that last part in, and that's great. So 4 total ways to travel from city 2 to city 1. First by bus, then by subway. Questions? All right. Let's look at number 9 then. It says, write an expression that represents the total number of ways you can travel between city 4 and city 1, first by bus, then by subway, with no more than one connecting stop. Was the value expression, was the meaning of the result? Go ahead and try 9. I'll give you a couple minutes. Expression, then plug in the numbers to do the math, and then write the meaning of that answer. Go ahead. This time from 4 to 1. I think we did that as well. Oh, we did 1 to 4. Identify the pattern, and it's pretty much the same one. Right, Caleb? Doing 9 on your own, if you haven't already. So just like in the table, but this time for just this. So we're going to go from city 4 to city 1. So that means the first number should be a 4 and the last number is a 1. These inner ones are always going to be the same. It's going to go 1, 2, 3, 4. So setting up the expression should be almost mindless, but then you have to go back and retract, all right, what's these values of these expressions? All right. I'm going to go ahead and write out the expression so that you can check it. But this should be bus 4-1 and then subway 1-1. Everyone get that first beginning right? And then just kind of keep that pattern going. Again, these two numbers on the outside won't change. I'll just change the inside numbers. So this would be bus 4-2 times S21 plus bus 4-3 times subway 3-1 plus bus 4-4 times subway 4-1. Any questions on that part? That should be the easy part now. The hard part's now going to the matrix and grabbing the correct element. So what's the correct element at 4-1? 0. S11, B42, subway or S21, B43, S31, B44, S41. What do we get? Row 4 should be 01. Yeah. Row 4, column 1. Going back to the question before 4, looking at the matrix. And then when we do the math there, you just get 0 plus 2 plus 1 plus 0, which gives me 3. What does 3 mean? Go ahead, say it again. From where to where? From city 4-1. Yeah, perfect. So 3 total ways, or 3 ways, or however you want to write. 3 total ways to get to city 4 to city 1 by first taking a bus, then a subway. Any questions there? All right, so one thing I need you to identify here is when we did this expression, if you look back at the matrix, I pretty much looked at what row on the B matrix. When I came over here and y'all were going back and forth, can I clear this so I can show you? Okay. Let's go back to those 2 matrices that were given to you and formed for you. When I was looking at number 8, what row did I pretty much take out every single number out of? Row 2. And when I was looking at the subway, what column did I pretty much take out all the numbers? 1. What do we typically do with arithmetic and matrices if I'm taking a row and a column of another matrix? Huh? Multiply them. This is multiplying matrices, row by column. We took every one of those products, summed them up, and then that was our answer. We got a 4 and then a 3. So when we were going back to that, to this guy, or what guy is it? Where's that? Where's that? To this matrix P, I now know that my answer for row 2, column 1 would be a 4 to represent all pathways from city 2 to city 1, which I think we already had filled out. Did we not? Yes. So that's where that comes from. So now if I take number 9, that was row 4 times column 1, right? And that result gave us 3. So I would then go to row 4, column 1. There would be my answer for that P matrix. So on number 10, it wants you to fill out the rest of this matrix. Now, we could do all these individually and write out all these expressions, or we can just do our matrix multiplication and get the answer that way just as fast. So if I bounce back to number 10, it says complete that matrix P. Well, now that I know matrix P is basically matrix B times matrix S, I can work this out. So matrix B was 1, 3, 1, 0, 2, 0, 2, 2, 2, 1, 0, 1, 0, 2, 1, 0. Take my subway, which was 0, 1, 1, 1, 1, 0, 1, 2, 1, 2, 0, 1, 1, 1, 2, 0. And so now I'm going to do row times column of each one of these. All right. So when we fill this out, you can do this side work. You can do it in your head, however you want to do it. But 1 times 0 is 0. 3 times 1 is 3. 1 times 1 is, so that'd be 4. And then 0 times 1 is 0. So this first answer would be a 4. All right. However you want to keep up with that math, if you have to write out that process, you can do that. I think these numbers are relatively small that we don't have to. So we did 1 times 0, which was 0. 3 times 1, which was 3. 1 times 1, which is another 1. So now I'm at 4. And then 0 times 1 is 0. So that means that when I multiply all these products and then sum them up, I get a 4 as my first element. That makes sense? So I'm going to do the same thing with the other 3 columns. 1 times 1 is 1. 3 times 0 is 1 times 2 is 2. So now I'm at 3. And then 0 times 1 is. Okay, so this one went from row 1, column 1. So 1, 1. This is now row 1, column 2. So that answer would then be right there. So your result of your row in the column that you're multiplying tells you exactly where it's going to go. So then we keep that process going. 1 times 1 is 1. 3 times 1 is 3, so that puts me at 4. 1 times 0 is 0. 0 times 2 is 0. So I have a 4. You're following pretty good? All right. Do the same thing with this one. 1 times 1 is 1. 3 times 2 is 6. So I got 7 now. 1 times 1 is 1. So I got an 8th one. And then 0 times 0 is 0. So this last number would be 8. So like I said, if you have to write it out, do that. Or some way to keep it organized. All right, once you have that first row, now you're going to do the same process, but now with the second row to each column, right? So a 4 by 4 times a 4 by 4 can definitely be time consuming. So let's do it. So 0, 0, 2, 2, that's a 4. 2, 0, 4, 6. 2, 0, 0, 6. 2, 0, 4, 0. Is that what y'all got? Oh, did y'all get 8 on that first one? Yeah, 8. Where did I mess up? So 2, 4, 6. Oh, 7, 8. Yeah, I have to go get my charger real quick. 2, 0, 4. One, two, two, three, two, three, 5, 2, 4. Check it that 2, 3, 4, 2, 3, 5, 4. My bad. Slow it down this next one. I was trying to catch up to y'all. I thought y'all were already done. It's just a process. You have to have your brain organizes things. All right, so 0 times 0 is 0. 2 times 1 is 2. 1 times 1 is 3. So that'd be a 3. 0 times 1 is 0. 2 times 0 is 0. 1 times 2 is 2. So just 2. 0, 2, 0, 0. So just 2. 0, 4, 5. Is that what y'all got? All right. Now if you've done that, it wants to now construct a matrix M where first you go by subway, then by bus. How would I figure that out? What would I need to do differently? Just swap it and do it again. We get the same thing. You're still working through it. Definitely check it. Come on, don't just look at it. Everyone good? Any mistakes I made? Made a mistake in all this matrix. All right. So the following question then goes, should these two matrices P and M, because that's what these were now called, should they be the same? Why not? I gotcha. They have different direction and routes. Go ahead. Very good. So when we first learned about matrices last semester, we learned that matrices are not commutative in multiplication. They are in addition. They just weren't in multiplication. So no, because matrices are not commutative in multiplication. And I stress to add that in multiplication part because we did find out that in addition they are commutative. The order didn't matter, but here it does. But you are in a real world scenario that totally makes sense because there's different options when going using a different route. And it looks like we're just looking at the numbers. I almost feel like you have more options if you go subway than bus. Just looking at the numbers in general versus the bus than subway. Any questions on that set? All right, so we're just going to kind of review some more topics. Looking at 13. So next that's 13 and 16. We're going to let A be this matrix. And part A says construct a matrix Z such that A plus Z equals A. So again, we went over this last semester. What matrix would I have to form in order to add it to another matrix to get the exact same matrix back out? The zero matrix. So my matrix Z here would have to be a 3 by 3 zero matrix. So anytime we want to add a matrix to another matrix and get the actual matrix back out, just like you would do with just regular numbers, you would add 0. In this case, we add the 0 matrix. Any questions there? Because how do we add elements? Or sorry, how do we add matrices? Right, in each corresponding element. So I would have to do 2 plus 0 to get 2, 3 plus 0 to get 3, and so on and so on. So that's why you would use the 0 matrix. Part B says, explain why k times z equals z for any real number k. Okay, then we're... Okay. If you let z be 1, 1, 1, then it would become KKK, like in that diagonal, right? But we want, just whatever, guys. Continuation of K's diagonally. Is that better? But I want Z to come out. Remember, Z is the 0 matrix. So why would, if K is a scalar multiple, why would it not matter what K is when I multiply to the 0 matrix to get the 0 matrix back out? Very good, because what do we do with scalar multiples or scalar multiplication? Well, yes, or decrease the size, right? But what do we do with that scalar in itself to the matrix? Not add, but how do you scale it? What operation are you using? Multiplying. I would multiply every element. So I would take whatever this value k is, and I would multiply it to every single one of these zeros just to get back 0. So explain why k times z equals z for any real number k. Any scalar k times a 0 matrix will be a 0 matrix. All right. So any scalar k times a 0 matrix will be a 0 matrix, because if I take that scalar and I multiply it to every single one of the elements, I'm still just going to get 0 out of it. Part Z then says the real number 0 has the properties of a plus 0 equals 0 and a times 0 equals 0 for all real numbers a. Why would mathematicians call Z a 0 matrix? Why do we call it a 0 matrix and not just 0 like you said earlier? It's a matrix of 0. 0 matrix is not just going to be 0. A 0 matrix is written like this: 0 dot 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 0 dot 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 0 dot 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 0 dot 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 is a continuation of a zeros infinitely in every direction. So yes, this is what we call a 3 by 3 zero matrix, but a 2 by 2 zero matrix will just be 4 zeros, and a 4 by 4 zero matrix will be 16 zeros, and a 5 by 5 will be 25 zeros, and just keeps on going with that pattern. So I can't just call it 0. That's a scalar multiple. I have to call it a 0 matrix, because that matrix of zeros will change depending on the size that you're dealing with. Does that make sense? All right. So that's I think there's only a couple more questions. So let's look at 14. So 14 says, suppose each city had a trolley car that ran a route between tourist destinations. The blue loops, which y'all don't have color on y'all's, so y'all can kind of look up here. These blue loops represent the trolley car routes. Remember that straight lines indicate bus routes and dotted lines indicate subway routes. Part A then says, explain why the matrix I shown below represents the number of routes connecting cities by trolley car in this transportation network. So if you notice, every one of these trolleys are just connecting to themselves. So how many ways do I got from city 1 to 1? 1, right? Well, that makes sense, right? Well, just trolley wise. So trolley wise, to get from city 1 to 1, I have one way. How many trolleys do I got from city 1 to 2? 0. How many from 1 to 3? 1 to 4. From city 2 to 1. But what about 2 to 2? And then so on, right? And then from city 3 to 3, and then city 4 to 4, and the rest of them will all be 0. So why is this a good matrix I for our trolleys? One more time. The trolleys don't leave the cities, right? So it says, explain why matrix I shown below represents the number of routes connecting cities by trolleys in this guy right here. So the trolleys never leave the city. Right, their city, depending on what city they're in, right? Which then makes sense. There should be 0 routes getting to any other city. Right? What is this matrix called? Because it doesn't seem to clarify it. The identity matrix. I'll go ahead and write that out for you. The identity matrix. What's good about the identity matrix? Why would we need the identity matrix? So that change. By doing what operation? multiplication. So if I multiply the any matrix to any other matrix, I would then bounce back with our new matrix or the same matrix. So when we look at part B there, it says recall that B is the bus route matrix. So show that I times B equals B and explain why this makes sense in terms of the transportation network. So if I take my I, which is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, and then take my bus, which I don't remember. 1 3 1 0 2 0 2 2 2 1 0 1 0 2 1 0. And if I could physically move a set of these numbers, I feel like it'd make a lot of sense. But if I took this row and I turned it sideways and I multiplied by this column, the only thing that's going to get to multiply is that 1 times 1, right? That's matrix B. From right above number 4, I had to go back a little bit. If you go right above number 4, it gave you B and S. Yeah. So therefore, it would just be the 1. And then it would do the same thing. If I pick this up, it would only get to multiply by 3. So if I was to multiply this identity matrix to everything, I would just, in fact, get the matrix B right back out. So again, explain why this makes sense in terms of the matrix network. By having the trolleys there, did it really change the amount of routes that you have to get from one destination? No, you didn't. Right? So trolleys just going from city to that one city doesn't change your amount of options you have going everywhere else. So that's why I can multiply and it not do anything. It'd be different if those trolleys were connected to other cities. Now we have a whole different kind of ballgame. All right, so part C, it says the real number 1 has the property that 1 times A equals A for all numbers A, and we call 1 the multiplicative identity. Why would mathematicians call I an identity matrix? Why do we call this guy right here? Okay. Okay. Can I go a little bit further? So we multiply it by itself to do what? To get the original outcome back out. But why would we call it an identity matrix and not just 1? Doesn't the scalar 1 do the same thing for us? If I was to take 1 and multiply every single element by 1, does it not pop back out as 1? Or not 1, but its original stuff? An original number it will. If I was to multiply everything by 1, it would still just be that value. Versus an identity matrix, we need to find out another one. It's just called an identity matrix because it's a matrix, right? So you get something that looks like this. I think they write it like this, dot, 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 0, dot, 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 0, dot, 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 1, dot, 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 dot. So that would be your identity matrix for all matrices. All right, so that should be just about everything y'all need, and then we'll review tomorrow.